Assalamualaikum warahmatullahi taala wabarakatuh. My name is Mohd Hazim bin Muhammad Sakri with the matrix number N1901162 and my supervisor is Dr. Hasliza Hassan. Today I will present my project about the smart plant adaptability and monitoring SPAM. So for the overall content is introduction, literature review and methodology. For the introduction, this system will sensor embedded in a container which is will be auto watering, auto lighting, auto humid and temperature control, and lastly will be monitored by using the IoT. For the my SM Gantt chart, as you can see, I rushed for the last week. The problem statement is this harsh condition or harsh condition in rural or urban, such as acidic soil, heavy rain, user farmer safety, which is the plant can just from home, and we can for third is plant or crop disease can be prevent because we just plant it in a container. So my project objective is to design a container that capable to mimic any best environment for plant to or crop to grow. Second, to develop an environment with a few systems involved. Third, to monitor the basic need of a plant to grow inside this project system. My project scope is a container we build with a non-MCU ESP32 soil moisture sensor, light sensor, temperature and humidity sensor. This project will equip cooling and heating system, artificial light system and moisture system. This project sensor will be read and seen by user using Android application which is Blink via Wi-Fi module. For a start, the project will apply to the smaller scope first, which is using a chili plant. Skip for the expected result. My literature review is this project 1. As you can see, this is a IoT enabled smart farming irrigation system, which is it show how automatic irrigation system that must have in the system, the basic component and the basic system. The previous project 2 is smart irrigation system. This project proposes a basic system for smart irrigation with some safety feature, but still the sensor used is the cheap one but ready to be upgraded. My previous project 3 is this project has some ways to control the light intensity with the light sensor. So IoT using by Google, and the IoT use is by using Google Sheet. My previous project 4 is plant monitoring system cum smart irrigation using both IoT. Use of both IoT can save space instead of having an Arduino with Wi-Fi module. But IoT is ready to cope without having IoT lot of library compared to Arduino. My project previous 5 is intelligent itinerary robot IIR for agriculture farm monitoring using IoT. This project use a robot with the embedded sensor in robot to make sure the sensor can work for a long time, and IoT monitoring. My previous project 6 is integration of water control with a drip irrigation system for agriculture application. This project system usually we use the pump water, but this time it using the pump water with the dripping system instead. My previous project 7 is base temperature control system owned by using an Android device. This project is show how to control AC appliance, which can modify to use my project, which is I will use the DC hardware. For the last previous project is control of light intensity via microcontroller for the efficiency of electrical energy. This project can be modified to control light intensity just using a DC source. So for my hardware and software use is, as you can see, capacitive soil moisture sensor DHT22, light dependent or LDR, not MCU ESP32, dual channel relay, DC motor pump, DC cooling fan, and DC LED lamp. For the software use is Arduino IDE, Blink application, SketchUp 2022, Hazim, and Proteus. For my methodology, as you can see, I start with the Arduino, not MCU ESP32 with the power supply, which is I can choose whether I will use the power bank or battery or the USB, which is all of this is within 4.8 volt to the 5 volt. So for the sensor I use is I have a 3 sensor, which is soil moisture sensor, which is a capacitive one, which is have a highly resistant to the water and soil acid. So the second is the white one is DHT22, which is humidity and temperature sensor. The third is LDR, the light dependent resistant. It will be a sun or outer light sensor. So the capacitive will work together with the water pump, DC water pump. When a certain threshold is do not exceed, it will trigger the pump to pump the water toward the dripping system. For the DHT22, it will send humidity and temperature, which is its feedback is cooling fan. The cooling fan will turn on when the status of the air is dry or has a high high temperature. For the LDR will be connect with will be sense the light, which is will turn on, which we will work only in the night, and only in the night which will turn on the LED lamp when the certain light intensity or lux is exceed. So I use the dual channel relay to connect the pump and fan. But for the LED, I just connect directly with the resistor and the power to the PWM pin of not MCU. For the 3D layout, as you can see, this is my unfinished 3D layout. So the moisture sensor will embed in the bottom of the pot because it's only because as I review all the article, I don't want to the sensor is above the ground, but it's have to the under the ground. So the cooling fan will be embedded or pasang in the above. This cooling fan also will prevent the disease from the humidity, such as fungus or other bug. Alright, thank you. Thank you for giving your time to read my slide. Yeah, thank you.